Okay, so it looks like I hit mute on the headset accidentally, so oopsies. Anyway, I got to record number 4 again. So, on the fall sports pep rally relay race, we have Mr. Campbell, and he's running 6 meters behind a student when the student is 40 meters away from the finish line. So let's just draw us a little picture. And there's the student, and this distance here is 40 meters, give or take. And Mr. Campbell is another 6 meters behind that at the beginning. And so, there we go. And so there we go. And this is 6 meters. Okay. And so this is Campbell initially. This is the student, and this is the finish line here. And so what we need to figure out with the student running at a constant speed of 8 meters per second, and Campbell running initially at 8 meters per second. So I'm going to start the student off the constant speed of 8.0 meters per second. Campbell initially, actually let me go with VC sub comma I, is 8.0 meters per second, and acceleration of Campbell is 0.5 meters per second squared. So who wins the race, basically, is the question. So there are different ways to approach this. The most straightforward way is to find out how long it takes the student to cross the line and then see where Dr. Campbell is at that time. So for the student, the distance the student needs to travel is going to be equal to the student's speed, or the student's velocity. Well, sorry, the displacement the student needs to go through is going to be equal to the velocity of the student times the time it takes. Now, this is, of course, depends on your choice of coordinate system. What I'm going to do is I'll do it in black. I'm going to say positive x goes this way, and I'm going to say x equals 0 is the finish line. This is a little unusual, but and so x for the student initially is negative 40 meters, and x for Campbell's initially is negative 46 meters. So the way we can set this up is to say delta x for the student, which is the student's final position, which is 0, minus his initial position, which is negative 40, has to be equal to the student's speed, which is 8.0 times the time it takes. So, this is just a fancy way of getting to the displacement the student goes through is plus 40 meters. And so you get 40 equals 8.0 times t, and then you get the time for the student to finish is 5.0 seconds. So then the question is, where is Mr. Campbell? So let's go with delta x for Campbell is going to be, well, his initial velocity, okay, times the time that passes, plus 1/2 times his acceleration times the time squared. Okay, and that's acceleration of Campbell, sorry. So, and this is going to be Campbell's final position, which is 0, and then negative, well, no, actually, sorry, we can't do that. We don't know Campbell's final position. So, x for Campbell at the end, xcf, we don't know that, but that minus his initial position, which is negative 46 meters. Okay, so that's the left-hand side expands into x final for Campbell minus x initial for Campbell. Okay, that equals Campbell's initial speed, which is 8.0, times the time that passes, which is 5.0, plus 1/2 times Campbell's acceleration, which is 0.5 meters per second squared, times 5.0 seconds squared. And so what this is going to come out to, this part here is 40. Let's see. Is this right? Yes, okay. So what you're going to get, actually I'm just going to do another line and page down one. So that gives me 5, but whatever. So Campbell's final position is going to equal, I'm going to bring this negative 46 over to the right-hand side, negative 46. This 8 times 5 is going to be 40, okay? And then plus the 1/2 times the 0.5 is 0.25. Well, it's 2, so it's 2.5 squared, so it's going to be 6.25 meters. And so Campbell's final position, which is x, I'm saying c comma f, Campbell comma final, is going to be negative 46 plus 40, so negative 6 plus 6.25, so 0.25 meters. So there you go. Campbell, after 5 seconds, Campbell is a quarter of a meter past the finish line. The finish line was x equals 0. Campbell is a quarter of a meter past that. The student is on the finish line at that time, so Campbell wins. And in response to the question, how much, if you want a time, then what you'd really have to do is run this equation, but instead of plugging in the student's finishing time, solve it for Campbell's finishing time by making this delta xc 46, okay? And then solve for t, which will be just barely less than 5 seconds, but that's how much Campbell wins by. The way I'm answering it is, saying, look, when the student crosses the finish line, how far past it is Campbell? And the answer is a quarter of a meter. So it's like when old-time race announcers, are talking about which horse is winning by how much. And they say, and Flipsy's your mother is leading Sassafras Saskatchewan by 2 noses, or whatever weird units they use for horses. I'm sure somebody can correct me on that. So anyway, the question was kind of vaguely worded, so it's sort of your choice how to answer it, and I'm answering it the easy way. So that's problem 4.